Section 2.6 has to do with addition of Cartesian vectors. So suppose you have multiple vectors and you would like to add them. So you might have, let's see here, this is the x-coordinate, the y, and the z axes. And let's say you have a force 1 and you have another one maybe going in this direction, force 2, and another one. And if you have multiple forces such as this and you have to add them, the best way to add them is using their Cartesian components. So for example, F1 should be written in terms of its x, y, and z components, as well as for F2 and F3. F2xi, F3xi, F2y, F3y, and what you do is you just add all the I components together, all the y components together, and z components together, and you get the resultant, which can be expressed as f sub r, which is just the sum of all your force vectors. And if we break it down into components, what it means is you take the sum of all your x components, take the sum of all your y components, and take the sum of all your z components. So we've covered a lot of equations, and let's now do a problem where we will practice using some of those equations. So it's very beneficial to memorize these. So I'll put them on the side. So let's look at this problem. Suppose we're given a force with a magnitude of 80 newtons. So this is 80 newtons in the x, y, and z axis. And we're also given this angle, which is called the direction cosine alpha. So we know alpha is 45 degrees. We also know the angle that it makes with the y-axis, and that's called beta, and it's 60 degrees. And what we like to find is to be able to find the Cartesian vector notation for f. They want to know f. So they want to know f of xi plus f of yj plus f of zk. That would be the Cartesian vector notation. So how do we go about solving that type of problem? So we go back to our handy-dandy formula sheet, and I inspect the equations that are at my disposal. And since I'm trying to look for a vector f, the two that pops out on these two sheets are either this equation or this equation. Unfortunately, for this equation, I need to be able to know the magnitudes of the components of the force. And I don't know that. I only know the magnitude of the force, and I don't know the components. Therefore, using this equation won't help me out. I go to this equation, and I do know some information about the angle alpha and beta. And I do know the magnitude of the force being 80. So this is a very good equation for me to actually try to use. So I'll rewrite that equation for this problem specifically. That would mean the force vector F is equal to the magnitude times the unit vector along that force, which can be expressed as the magnitude of the force times the cosine alpha I plus f times cosine beta j plus f times cosine gamma k. I do know the values of f. That was given to me. That's equal to 80 newtons. So f is equal to 80 newtons. I also know the angles alpha and beta because they're given to me here. So alpha is equal to 45 degrees. Beta is equal to 60 degrees. So the only one I don't know is gamma. So how do I go about finding that? So I go back to my sheet again, right there. And I want to be able to find gamma. And I take a look at all the formulas that I have available. I could possibly use this, maybe, but I look at it closely and I say, no, I don't know the components AX, AY, or AZ, so that's out. That equation is out. It's not even relevant to us. So I need that gamma, and I come up to this equation, and I note that I have alpha, which is equal to 45, beta, which is equal to 60 degrees. Therefore, I can solve for gamma. So that's the equation I'm going to use. Cosine squared alpha plus cosine squared beta plus cosine squared gamma is equal to 1. I know these. I can solve for that, which would be cosine squared of 45 degrees, cosine squared of 60 degrees, plus cosine squared of gamma is 1. You solve for gamma. Cosine squared gamma is equal to 1 minus cosine squared 45 minus cosine squared 60. That would still simplify to something that looks like this. And now if I do the calculation, it turns out that cosine of gamma is equal to 0.5, which gives me gamma is equal to 60 degrees. So I take all of this, substitute it into that main equation, and I get my Cartesian vector notation for F, which is equal to F, which is 80 newtons, times cosine of 45I plus F, which is 80 newton, times cosine of 60 degrees J, plus I have 80 times cosine of 60 degrees K. I performed the calculation, and my final Cartesian vector notation for my force F turns out to be 56.6I plus 40J plus 40K newtons. And that is the final answer. So I box it, and I tell everyone that's my answer.